Hi, Assalamualaikum. Welcome back to Check Your channel. Okay, today we continue with our next part of mathematical modeling, chapter 8, mathematics form 5. Okay, in previous class you have know what is mathematical modeling. So now in this video I will cover on next part in learning standard 8.1.2. Solve real life problems through mathematical modeling, which involve the following functions, which are linear functions, quadratic function, exponential function, and communicate the mathematical modeling process implemented. Okay, so just a refreshment, what is linear function? Linear function is a graph resembles a straight line. And quadratic function, a curved graph in the form of parabola. Okay, the quadratic function form parabola. Okay, the curve may rise and then fall, or fall and then rise. And another one is exponential function. What is exponential function? It is a curved graph illustrating an increase or decrease in values of a data at sharp rate. Okay, the exponential function can be written in the form of equation y equals to ca power of x, where a is a positive real number and a cannot be equals to 1. Okay, means that other than 1, okay, positive real number, okay, other than 1, and c is an initial value. Okay, for example, C is 1, A equals to 2. And this graph y equals to 2 power of x is shown in the diagram. Okay, here is examples of exponential function. Okay, you can look at this graph. The graph increase at a sharp rate. Okay, all right. So now look at example 2. Okay, we look at example 2. Amin traveled 405 kilometers on 45 liters of petrol in his car. Okay, if Amin wishes to go to a place which is 198 kilometers away by car, how much petrol in liters does he need? Solve this problem through mathematical modeling. Okay, when question asks you to solve problems through mathematical modeling, you have to go through all the process. Okay, you have 6 process. Okay, start from identify, and then this final steps is you report the modeling. Okay, all right. So first you have the step of identify and define the problems. Okay, you look at what information you have here. Your information you have here is the 400 kilometer travel, the distance of travel of 400 kilometer, and the petrol consumption is 45 liters. And now Amin wish to go to place which is 199 198 kilometer, and you want to know what is the petrol consumption. Okay, so you just write out what is the problem. Okay, the problem is to determine the volume of petrol required for 198 kilometer, and we know that the farther the travel, the more petrol we require. Okay, thus the amount of petrol varies directly with the distance we travel. Okay, now what you know here, what you can see here, you have to apply variation here, and then you have the rate, ratio, and proportion. Okay, so here in the first step, you identify and define the problem based on the situation given. Okay. Right, the second step is to make assumption and identify the variable. Okay, you have to make a simple assumption, okay, based on the real world problem given. Okay, so here we assume that the driving speed for both 405 kilometer and 198 kilometer routes are the same. So we make a simple assumption. Right, let x represent the distance. So now we give the variable involved in this problem. Okay, let x represent the distance traveled and y represent the amount of petrol required. Okay, then we use the knowledge of variation. Okay, y varies directly with x. Hence, y equals to kx, where k is a constant. Okay, this one you have learned before. Okay, all right. The next step is the third step is apply mathematics to solve. Okay, so you use your knowledge about the variation. All right, so substitute y equals to 45 and x equals to 405 into y equals to kx to find what is k, what is the constants. Okay, so we solve this one by using mathematics. We apply the mathematics in this problem. All right, so we get k equals to 1 over 9. Therefore, here we get the model is y equals to 1 over 9x. Okay, this equation describes the relationship between the amounts of petrol required and distance traveled. Okay, when x equals to 198, so we can find what is the petrol consumption. Okay, so by using the variation that we have go through in these steps. Okay, so y equals to 1 over 9 times 198, the distance. Okay, so the petrol consumption for 198 kilometer is 22 liters. Hence, 22 liters of petrol is required to travel 198 kilometer. Okay. Next, what you have to do is you have to verify and interpret the solution that you use in applying mathematics knowledge. Then you verify. Okay, verify to interpret it in the context of a real world problem. Okay, we may not be able to use the linear function model. Okay, this one is known as linear function model. Okay, all right, because the when we draw the graph, we will get the straight line. Okay, all right. So now, in verify and interpret the solution in the context of problems, we may not able to use the linear function model y equals to 1 over 9x in all situation. Okay, why? Okay, for example, in the 405-kilometer route, it is true. Okay, if the 405-kilometer route is through towns and cities, and the 198 route is through highway, maybe okay, there are this different in the route for the two different distance here. Okay, thus the car will use up petrol at a faster rate, okay, in the first route compared to second route. Okay, because when car go through towns and cities, okay, the petrol consumption are different compared to highway. Okay, the petrol consumption will be different. When this is translated to real world situation, the linear function model obtained is not suitable to solve the problem. So you make a verification based on model that you have created. Okay, so give your support, okay, the support of your applying mathematics with this graph, okay, the linear function. Okay, all right. The next step is you have to refine, okay, the mathematical model. In this problem, so you write the refining for the mathematical model that you have created. In this problem, we are not able to refine the model due to limited information given. Okay, just give your justification about what are the uh, kekurangan of your mathematical model created. Okay, all right. So here you give um justification about uh, this model is not able to use for other problem because it is limited information given. Okay, all right, and then the final step is to report the findings. Report the findings means that you write back what you have go through from the first step until the fifth steps. Okay, all right, that one is example for the linear function. All right, for example 3, okay, you will go through the quadratic functions. Okay, example of quadratic functions. Okay, look at this example. The diagram below shows the cross section of a river. A hydrologist measures the depth of the river y meter. Okay, sorry, my diagram quite blur here. Okay, you can just refer to your textbook for the clearer picture in page 237. Okay, so this one is the depth of the river in meter, y meter. Okay, at different distance x, okay, from the river bank. Here you have from the river bank the distance from y. Okay, okay, the distance of y and the river bank, okay, represented by x meter. The result obtained are given in the following table. Okay, all right. This one are the example given. Okay, based on the measurement, the distance between the from the river bank. If the difference in distance is 0, then the depth of the river for the y meter is 0. Okay, if x equals to 4, the depth of the river is 1.5 meter. Okay, if the distance from from the river bank is 8 meter, so the depth of the river is 2.3 meter, and so on. Okay, the question asks you to show how the hydrologists use the data above to determine the depth of the river through mathematical modeling. Okay, right? So you have to show the full steps of mathematical modeling, all the components of the mathematical modeling. All right, based on these problems. All right. So the solution is step number one, identify and define the problem. So the problem now is how to determine the depth of the river. Okay, and you can give other how you identify the problems. Okay, this one just example. Okay, all right. You can give details. Okay, you can give more details about the problems. All right. Okay, the second step is making assumption and identify the variables. Okay, so make a simple assumption. Okay, assume the river is deepest in the middle with the depth decreasing to 0 at the edge. Okay, so this one is the assumption we make. Okay, a simple assumption. Okay, all right. The two variable involved. Okay, here we give the variable for this problem. The two variable involved in this study are the depth of the river y meter and the distance from the river bank x meter. So you have to use what are given, the variable given in this problem. Okay, now, okay, the third step is to apply mathematics to solve problems. Okay, all right. So what you have to do to apply this to apply the mathematics knowledge. Okay, you write the distance from riverbank and the depth of river as set order pairs xy. You have learned it in form 2. Okay, the ordered pair on how to draw the graph function. Okay, and then you draw a graph for the data. Okay, all right, so you apply mathematical knowledge here. Okay, then you plot you plot the graph based on the table given, the value and the tables of values. Okay, and then the data seem to rise and fall in manners similar to a quadratic function. Okay, when you join all the point here, okay, the point that you have plotted, okay, you will get a parabola. Okay, this one is known as parabola. Okay, so this one is a quadratic function. Okay, the graph drawn shows the curve of best fits and resembles the graph of a quadratic function. In mathematical modeling, to represent the actual situation, the approximate value is used. Okay, all right. Based on the graph, the depth of the river is 3 meter when the distance from the river bank is 15 meter approximately. Okay, so this one just approximate value. Okay, you look at here. Okay, when Okay, 3 meter. Okay, this one y. Okay, y is the depth of the river. Okay, this one is the distance. X is the distance from the river bank. Okay, when the distance from river bank is 15 meter, okay, means that this one is the deepest part of the river. Okay, kat tengah-tengah tu, yang paling dalam tu. Okay, 15 meter. The distance is 15 meter from the river bank, and the depth of the river is 3 meter. Alright, so this one is based on what you apply the knowledge of mathematics in this problem. Okay, we use the quadratic function. Alright, now we have to verify. Okay, the next step is verify and interpret the solution in the context of the problems. Okay, determine the related quadratic function of the form. This one is the general form, y equals to ax squared plus bx plus c. Determine the constants a, b, and c by substitute any three data. Okay, because now we have to verify what we have done with the previous step. We have to verify. Okay, so we use this function. Okay, the general form of quadratic function. Okay, and we substitute. Okay, any three from a value from the data we have. Okay, for example here 0 0, 25 1.7, and 30 0. Okay, all right, this one is based on the table. Okay, this one is based on the table. Okay, this table. All right. Okay, so here we just substitute the value y0. Okay, based on this ordered pair y0, a in the bracket 0, this one is value x. Okay, and then b in bracket, put the value x plus c. All right, and then when we solve this equation, okay, we get c equals to 0. Okay, for the first equation we have. All right, next when we substitute the second ordered pair, okay, x25 y 1.7, okay, substitute in this quadratic function, we get this equation. Okay, 1.7 equals to 625a plus 25b plus c. Okay, and the third data, okay, based on the third data, okay, we substitute the value, okay, x30 y0, and we get this equation. All right, since the first equation c equals to 0, the system of two linear equation in two variable is we take these two equation. Okay, so means that we apply the simultaneous linear equation to verify the mathematic model. Okay, so this one is the first equation, and then here is the second equation, and then you can use substitution method or elimination method to find what is value a and what is value b. Okay, so here when we solve by using substitution method, value a is negative 0.0136 and value b is 0.408. All right, hence the the possible quadratic function. Okay, here we state as possible. Okay, all right, the possible quadratic function is y equals to, okay, negative 0.136x squared plus 0. This one is value a, this one is value b, and value c is 0. Okay, so here no y-intercept. Okay, we have the value of y-intercept is 0. All right, and then we substitute x equals to 15. Okay, how we know what is value x, based on the step of we draw this graph function. Okay, the maximum value. Okay, the maximum value for this function. Okay, maximum value of x, maximum value for the y. Okay, all right. So these steps. Okay, substitute x equals to 15. Okay, in this equation. Okay, to find what is y. Okay, and then here y we get 3.06 approximate to the answer obtained from the graph. Okay, look at here based on this graph. Okay, all right, based on graph we just get approximate value. Okay, 3.0. Okay, because we cannot plot, kita tak tahu nak mana nak plot 3.06 tu. Okay, so we just will get this value. Okay, based on graph we draw. So at this step we verify. Okay, we verify the value is 3.06. Hampir-hampir based on hampir-hampir value tu based on graph we have drawn. Okay, right. So the next step is refine the mathematical model. Okay, so this model we get this one lah. Okay, y equals to negative 0.016 x square plus 0.40x and value c is 0. Okay, then next we refine the mathematical model. So we have to make any other assumption that more complicated. All right. So for this model, okay, for this model, we assume that the river is the deepest in the middle. Okay, so this one is the assumption we make. Okay, for the this problem to solve this problem. Okay, this may not be true for some other rivers. Okay, tak semua river sama macam keadaan begini. Okay, alright. Yang this one kita andaikan the deepest, okay, kedalaman yang paling dalam itu di tengah-tengah. Okay, tapi in real life situation, okay, not all akan jadi macam ni lah. Okay, so a new model will be needed if we have new assumption. Okay, kalau kita ada assumption yang lain, okay, so kita kena create another model. Alright, the answer will be more accurate if more data have been collected. For example, we know what is sungai yang mana, for example, okay, dan kita ada lagi information yang untuk membantu kita dapat more accurate mathematical model. Okay, the final step is we report the findings. Okay, means that we write full report based on the modeling framework structure that we have go through. Alright. Okay, that's one for the quadratic functions. Alright, now we go to another example. Example 4 is about the exponential function. Okay, compound interest. Okay, based on example 4, compound interest is interest that is calculated based on the original principle. Okay, this one you have learned in form 3 about the savings. Okay. What is compound interest? Compound interest is the interest that is calculated based on the original principle and also the accumulated interest from the previous period of saving. So this one is the meaning, the definition of compound interest. What is compound interest? Okay. At the beginning of a year, Mr. Gomez had a save 20,000 in his savings account with an interest rate of 4% per annum and okay, sorry, tersilap ejaan di sini. Okay. Okay, 4% per annum and the interest is compounded once a year. So what we have here, the information we have here is the principal, 20,000, the rate of interest, okay, 4% per annum, and this savings, the interest will compounded once a year. Okay, derive a mathematical model for Mr. Gomez's total saving after 3 years of savings. Okay, so you have to make a mathematical model about Mr. Gomez total savings. Okay, for 3 years. Okay. Solve this problem through mathematical modeling. So the first step is identify and define the problem. So we write all the information we have and then we define what is the problem. Okay, here Mr. Gomez is given compound interest which is compounded once a year. Okay, based on the information given. His principal is 20,000. The yearly interest rate is 4%. Okay, now define the problem. Derive the mathematical model for Mr. Gomez total saving at the end of T years. Okay, so this one is the first step. The second step is make assumption and identify the variable. So we make a simple assumption. Okay, assume Mr. Gomez did not withdraw or raise his saving throughout the period of saving. Okay, so this one is a simple assumption we make. Okay, to create this mathematical model. Okay, what are the variables involved here is the principal, the interest rate, the number of time interest is compounded, and times in years. All right. Okay, now we have to apply mathematics to solve problems. Okay, assume that we do not know what is the formula for the compound interest. So we use our other knowledge about mathematics. Okay, keep in mind that when calculating the compound interest, each year we have 100% of the principal plus 4% of the previous balance. We construct a table as follow. Okay, this one is an example. Okay, we construct a table from year 1 until year 5. Okay, to support our answer. Okay, to apply the mathematics model. Okay, for the first year, the principal is 20,000. The interest is 4%. So this one is how to get the interest is principal times the rate. Okay, because it's compound once a year. Okay, so the total saving for the first year is principal plus interest. This one is the principal. Okay, 20,000 times 0.04 is the interest. So we can use the uh, our knowledge about mathematics. Okay, this one we factorize 20. Okay, factorize 20. Okay, in bracket 1 plus 0.04. Okay, when we expand, we will get this one, this value. Okay, 20,000 plus 20,000 times 0.04. Okay, all right. So the total amounts of saving for the first year is okay 20,000 in bracket 1.04 because 1 plus 0.04. For the second year, okay, the value of the principal is based on the previous balance. Means that the principal plus interest for the first year. So this one is the principal for the second year. Okay, and then how to get the interest? The principal for the second year we multiply with the rate. Okay, 4%, and then the total saving. This one. Okay, here is the principal 20,000 times 1.04 is the principal for the second year. Okay, the next part here, okay, is how to get the interest. Okay, and then we simplify. Okay, we factorize. Okay, we factorize these two value 20,000 times 1.04 and then in bracket 1 plus 0.04. Okay, so the total saving for the second year is, okay, actually this one, okay, 1.04 times 1.04. Okay, what we get here is 0.04 square. Okay, so we apply what we know about the mathematics knowledge. Okay, and okay, you can go through for the third year, fourth year, and the fifth year. Okay, how to get the amount of saving. Okay, here is what we get here is the value of saving for the end of each year. Okay, look at here 20,000 times 0.04 power of 1. The second year 20,000 times 1.04 power of 2 and so on. Okay, now we have to verify the model that we go through for the applying the mathematics. Okay, we have to verify and interpret the solution in the context of the problem. So based on the table, at the end of every year, the amount of saving is a power of 1.04 times the principal. Okay, the principal is 20,000 and the power corresponds to the number of year of saving. Okay, we look at here for the third year, for example, for the third year, this one is the principal multiplied by 1.04 power of 3. Okay, power of 3 is the uh, year. Okay, number of year. Okay, so we can generalize these patterns to a mathematical modeling by letting P represent the principal of the savings, T represent the number of years, R represent the yearly interest rate. Hence, the mathematical model is what we get here is AT. Okay, we look write as AT equals to P in bracket 1 plus R close the bracket power of T. Okay, we note here that 1.04. Okay, this one we get from the table that we create when we apply the mathematics. Okay, 1.04. Okay, how we get 1.04 is actually 1 plus 0.04. Okay, here. Okay, this one 1.04. How we get 1.04 is actually 1 plus 0.04. Okay, so we simplify it as 1 plus r. Okay, because we have to uh, uh, what we have to make sure this model can be applied with the other problems. Okay, so in this problem, given the interest rate is 4%. So what about other problems? So we just represent the rate of interest as R. Okay, so that's why we get this model. Okay, okay, what is AT? AT is the amount of saving after T years. All right, so this mathematical model is an exponential function that allows us to calculate the amounts of saving if the interest rate is compounded once a year for T years. Okay, so this mathematical model applicable for the compounded once a year, interest that compounded once a year. Okay, so the graph shows an exponential function. Okay, AT equals to 20,000 times 1.04T. Okay, based on what we have in this table, we transfer into a graph. Okay, we plot based on the table and we get this type of graph. Okay, what you can see here, it is sharp increase. Okay, sharp rate of increase. Right. The graph of the amount of savings after T years, AT, shown an exponential growth as time increase. Okay, so this one is examples of exponential function. Okay, when you use the mathematical model, support your answer with graph. Okay, what types of graph involved in the problem? For example, just now in example 2, it is about linear function. So we draw the linear function graph. And then example 3, it is about quadratic function. So we draw plot. Okay, based on the information we have in applying mathematics, we plot the graph. Okay, to support our process of mathematical modeling. Okay, in this part, in this example, exponential function. Okay. Next steps, okay, the step yang kelima, refine the mathematical model. Okay, so we refine the mathematical model. AT equals to P in bracket 1 plus R power of T is used for annual compounding. Okay, this one is we use for this problem. In reality, interest is often compounded more frequently. For example, compounded semi-annually or quarterly. Okay, if the interest is compounded monthly, the interest rate R is divided amongst the 12 months because 1 over 12 of the rate is applied each month. Okay, maksudnya rate tu perlu dibahagikan dengan 12. Okay, if it is compounded monthly. The variable t in the exponent is multiplied by 12 because the interest is calculated 12 times in a year. If the interest is compounded monthly, means that 12 times will be compounded in the year. Okay, so for t, it have to multiply by the numbers of interest compounded in the year. Hence, the mathematical model becomes, okay, from this model that we have used for this problem, okay, we convert into this mathematical model in order to make it can be used for other real life, real world problem. Okay, this one we make assumption that if it is compounded monthly, okay, so the rate have to divide by 12, and then the time must be multiplied, okay, the time must be multiplied by numbers, how many numbers of compounded for that year. Okay, all right. In general, if the interest rate is compounded n times, means that not only 12 times, okay, for example, maybe compounded quarterly, so we use that times of compounded, number of compounded, okay, how many times the interest compounded, we change into n, okay, okay. If the interest rate is compounded n times per year, the mathematical model is, okay, this value 12 we change into n, okay, so this one also change into n. So this one is model that can be applied to other real world problem. Okay, so here we make more, we refine, okay, we refine our mathematical model in order to be used to other real world problem. Okay, the final step is report the findings. Okay, the findings, you report all the step you have go through based on this mathematical, the modeling framework structure. Okay, so that's all. Okay, that's all for how you what is it, how you apply, okay, how you apply the mathematical model to solve real life problems throughout mathematical modeling, which involve the function of linear, function of quadratic, and function of exponential. And you communicate the mathematical modeling process implemented. Okay, so for your uh, just for your okay, sorry, okay, for further understand, okay, about how to solve the problems by using this function, okay, you have to go through, try to do the self practice 8.1b, question number 1 and question number 2 from your textbook page 240. And if you have any problem, don't hesitate to message me. Okay, that's all. Bye.